Hi everyone, and welcome to this lecture. Here we are going to create a function that performs the hypermutation of the antibodies. And let's remember, the hypermutation is inversely proportional to the affinity of the antibody. Antibodies with good affinity have less mutations, and antibodies with a poor affinity suffer more mutations. Let's create the function hypermutation. Here we have two parameters, clones and factor. This factor will be the mutation factor, the beta, in this formula right here. Let's create a variable called hypermutated, an empty list, clones. Here we have a list comprehension, x index y for x in clones. For I in clones, f equals affinity I number. Here we have the hypermutation rate, hyperrate. So here we have this formula right here, 1 minus affinity divided by 121. Why 121? Because we have 121 positions to match with the antibody. And here we have the factor, which is the mutation factor. Hyperm, let's create a variable called hyperm, which is another list, for j in I. J represents the elements of the antibodies. Rand equals random dot random, a number from 0 to 1. If rand is less or equals the hypermutation rate, then if j equals 0, hyperm dot append 1, and if j is 1, then hyperm dot append 0. So this is the mutation. Else, if this random number is higher than the hypermutation rate, then hyperm dot append j. Let's create a variable hypermutated dot append hyperm, and finally let's return hypermutated. Let's run this function. Let's copy this. Here we will put the same variables as before. For I in cloned, print I. For I in hypermutation clone, let's establish the mutation factor as 0.1. Print I. Let's run. So here we can see the cloned antibodies without the hypermutation, and here we have the antibodies with mutations right here. So this was the lecture where we built a function that performs the hypermutation. In the next lecture, we are going to run the algorithms to find the solutions for this problem, to generate better solutions, better antibodies. I see you in the next lecture.